Today we're going to present a case study on how Verge Health brought their system to life on AWS. We'll talk in a pretty good amount of detail about why they decided to do this, what were the business drivers. We're going to get very deep technically, so it's a 300-level session. We're going to talk about specific techniques. We're going to talk through some code examples and go through some ways that we automated the process. And then we're going to talk a little bit about some pre-migration optimizations we made, some post-migration optimizations, and why we did it that way. And then we'll talk a little bit about some of the business results that came of all of this technology application. So my name is Jerry Miller. I'm the founder of Cloudticity. We help healthcare organizations design, build, migrate, and manage HIPAA-compliant solutions on AWS. I'm joined by James Lawson, the Chief Solutions Officer at Verge Health, who's our customer. So James is going to talk a little bit about some of the business drivers that led to it, and then I'll dive deeper into the technology. James?
Great. Thanks, Jared. Can everybody hear me? Can you hear me now? Hey, there you go. Great. Thanks so much. I'm James Lawson, Chief Solutions Officer with Verge Health. First to start off, I think this is one of the unique conferences where they don't do the whole everybody turn off your cell phone thing at the beginning. I actually was speaking at HIMSS last year or the year before, and I was speaking and somebody's cell phone was going off and on the front row, and I thought, man, that's really rude. It was my cell phone, so I'm going to turn mine off. So I don't do that. That'd be kind of a bad deal. This morning I had our stand-up with executive management. First guy on there said, it sounds like you either are in Vegas or you have a cough. And I was like, well, both of those things are true. So I apologize if I cough a little bit for you. And I'll start off with a cough. So first thing, to tell you a little bit about Verge Health. Start off with me, I guess, for just a moment. I'm the Chief Solutions Officer responsible for products and technology with Verge Health. And who is Verge? This is not a sales presentation for Verge Health. Just want to talk to you guys a little bit about what we do and how we do it so that you can understand what the migration to AWS meant for us. So Verge Health is an application. We've got about 900 hospital system clients across the United States. That's about 14,000 providers monthly using our system. About a little over 17 million actions managed on an annual basis with about 500,000 active users. So quite a large scope of users across the United States. Our challenge primarily was, how are we going to modernize a single on-premises data center and really not address our physical redundancy problems. Our Converge platform has over 900 hospital systems you guys saw before. Kind of where we started at there back in August prior to this. Really what Verge does, let me back up and kind of explain what Verge does. First off, Verge does GRC for healthcare, really, which that is governance, risk, and compliance for healthcare. So what we do is we document actions that happen within healthcare, specific events, doing maybe root cause, claims, credentialing, et cetera, for hospitals so they can actually achieve great outcomes. So this data that we get, we help enable those hospitals to achieve highly reliable healthcare. And in doing that, we have to have highly reliable systems, right? Lots and lots of PHI, so you guys understand. Of course, with that PHI, we have a lot of not only PHI, but very, very sensitive data. So if something bad, awful goes wrong in a hospital, patient falls, medication error, et cetera, they're documenting that information in our system. So that data is extraordinarily sensitive, and we have to protect that data. Also, there's a significant amount of regulatory requirements, as you guys probably know. From a HIPAA perspective, you guys are in this track. So a lot of data problems we have there. Of course, all this data also exists outside of the EMR. So what our system primarily does is take that data so that you can actually perform patient safety work product outside of the EMR and go through those root cause analysis and have kind of a free location that's not subpoenaable, if that's a word, for lawyers so that you can actually make care better for our customers, which primarily is a patient. So in August of last year, we said we have a single geographical data center. And for us, while we had I'm having problems here. Sorry about that. There we go. Sorry about that. So why do we want to migrate? We talked about having a single physical location, which we had redundancy within that physical location, but that redundancy was a rack that was just on the other side of the room. So we had servers across there, which is not really redundancy. Spent a lot of time in Texas Medical Center at the beginning of my career at St. Luke's Episcopal Health System in Houston. And we had some pretty significant events through Tropical Storm Allison, a couple of other tropical storms, and a couple of hurricanes there, which mandated that we had physical separate redundancy, not just, two boxes next to each other, but physically somewhere else. For us, that was extraordinarily important. With our application, we also had a tremendous amount of VPNs to individual hospitals. These VPNs are set up for these 900 different customers, and we have HL7 coming inbound on all those. So that's a 24/7 operation. So when we looked at what we had to do, we were with a vendor that we had been with for a long time from a hosting perspective, and we weren't getting the greatest performance, of course, and we looked at what we would do. So really looked at 3 different components for that migration. The first component was really agility. We needed to address agility and be able to have the ability to bring on a customer or bring on hundreds of customers, or maybe one customer that had 10,000 providers, and be able to take those providers and put those folks into our system. One of the issues we had, of course, with doing that is, we had to monitor and predict that growth with a traditional hosting model. And if we were wrong, we had to get bare metal in place, and that bare metal had to be there, and it was taking weeks for that to occur, right? So that's a big piece for us. We also, again, talking about scalability, from an agile perspective also, we wanted to be able to do quick hit projects, for example, and be able to spin up a server to do some work on, to have a harebrained scheme from Tom, one of our guys here, be able to do that in quick fashion, and really a normal data center didn't allow us to do that. Also, of course, the bean counters in the room, if you're here, we had to worry about cost. So from a cost perspective, we were looking at addressing that redundancy and component from a redundancy perspective with having to have maybe a second data center in another geographical location. And those were one-to-one bare metal type servers. So it's expensive to have full redundancy, right? And even if it's a hot standby, or if you're using software to do that, it's still an expensive component. So we had to look at solutions that wouldn't break the bank effectively. Also, we had to figure out who's going to be our provider. We were lucky in that, and again, we're going to talk for a minute about kind of our journey, and then after Jerry talks a little bit about how we got there, we'll talk about some of the operational benefits as well. So in regards to finding who our partner was, we were lucky, as I said. We were already a SaaS-based application, so we weren't rooted into a single location. We could move that around if we wanted to, so that was good for us. Another thing that we looked at a lot of different providers. AWS is not the only provider we looked at. We actually have a Microsoft stack underneath us, so it made an awful lot of sense for us to look at Azure. And so we spent a lot of time going through that, looking at cost-benefit analysis and looking at the tools. And for us, it really made a lot of sense for us to choose AWS, really from the tool set perspective, and also looking at some of the partners they had in place. One of those partners, Jerry will talk to you a little bit about that in a minute. We also looked at partners to help us do that migration. Our migration was extraordinarily aggressive, as we'll talk about in a few minutes. And we knew that we couldn't do that ourselves, specifically because we were trying to run a software company, right? Not trying to run a hardware company. So understanding that we had to make that migration, we looked at several different providers that were in the group in some different areas. Specifically, we chose Cloudticity because they were really in the healthcare space, did a great job for us. Of course, I don't want to say that too much. We'll let you go through that. So I'll stop there and let Jerry talk to you about exactly what we did.
Great, thanks, James. So understanding what the objectives were was critical for us to help work with Verge Health to build the path to success. One of the critical factors was speed. So we had 3 months to effect this migration and shut off the data center. So that factored heavily in the decision around the process. We also wanted to make sure that in the migration process, we were addressing the issues of agility, of cost, of introducing a higher level of availability through redundancy, of introducing better disaster recovery. So all of these factors had to kind of merge and match in order for us to call this a successful product. So the migration process was get them up onto AWS as quickly as possible, get them as optimized as possible during that process, and then figure out a post-migration plan to continue the optimization to full desired state. The way that we did that was by following a set of configuration principles that we follow for every customer. I'm going to show you a simplistic diagram, and it's going to look probably like every other talk you go to, but it's really important to be successful on AWS to follow these principles to the letter, particularly some twists that we put in for regulated markets such as healthcare, which have to meet HIPAA requirements. Remember that for most of our customers, a HIPAA breach would be an end-of-life event for the company. And so that thinking factors into every technical decision and every process decision that we make. The first thing is everything has to be in a VPC. That can be. Obviously, you've got DynamoDB and non-VPC resources, but you have to be able to control your networking exactly. You have to be able to control your access exactly. You have to be able to control your monitoring exactly, and that cannot be done for things like EC2 instances outside of a VPC. The second thing is you always have to use multiple availability zones. You have the opportunity to dynamically create resources that exist in multiple physical locations so that you have failover, you have redundancy, and the overall system becomes resilient to the failure of any component of that system. And that can only be accomplished with multiple availability zones. We're also really deliberate about our subnetting. So very little goes in a subnet that is directly connected to the internet, so that we have full control over ingress and egress of traffic at the point where most breaches and hacks occur. Private subnets are really where we deploy most of the infrastructure, and we're able to very tightly control how traffic flows between the two. So we use load balancers to distribute traffic to multiple instances across multiple availability zones in very defined subnets where we know exactly how traffic can flow. For HIPAA workloads, we like to go a little bit above and beyond some of the standard AWS security controls, and we're pretty partial to the Palo Alto VM series firewalls. We use those for a number of techniques. So all ingress and egress to the internet happens through a Palo Alto firewall. And we'll talk later about some of the advanced features that we really like about that product. We've been through a few, and we're kind of sold on that one right now. It also supports both point-to-point VPN connections as well as VPN connections from individual workstations. So here we've got a single device that can control every type of traffic that happens to and from the internet. And that's really the only thing that goes into a public subnet. Everything else goes to the private, and we can very tightly control routing of traffic through that Palo Alto device. Another thing that we always try to do is to put all of the EC2 instances in auto-scaling groups. Now, we do that even in instances where you're not auto-scaling. Why would you do that? Because if you say I need to auto-scale to an instance of 1, and that instance goes away for whatever reason, the auto-scale group will regenerate it. So auto-scaling groups serve two purposes in this configuration. Number one, to actually auto-scale, to dynamically add and subtract resources as necessary, but they also serve to build a self-healing system. And because you're redundant across multiple availability zones, if an EC2 instance goes away, all your traffic gets routed to the other AZ until the auto-scale group recreates it. And so failures of things like servers just dying literally become non-events. Your customers are never affected, and the system fixes itself. We have very deliberate configuration of overall general AWS services that we use across all customers like Verge Health for HIPAA configurations. One is we use AWS config, and we turn AWS config on in every single region, even if you're only in one region. Now, why would you want to do that? Well, somebody might deliberately, or more likely accidentally, create a resource You forget to select your region, and you create an EC2 instance, and maybe you forget about it, and suddenly that becomes a pathway for an east-west traversal attack. And so we need to be able to identify when that happens, and we need, for HIPAA audit purposes, to log all of the kinds of changes that happen. And because we can inadvertently create resources or intentionally create resources in any AZ around, or in any region around the world, it's best practice to always turn on AWS config across the world. We use CloudWatch extensively, CloudWatch alarms, CloudWatch logs, to identify what's going on inside of the application and to not only monitor that proactively, but to respond to events automatically. So CloudWatch events can trigger Lambda functions that go do things. We'll talk in more detail about that. Interestingly, it's very easy to emit custom CloudWatch metrics from your application. It can be done with a cron job and a curl command, for example. And so while AWS provides thousands of metrics out of the box, you can also instrument your systems and your applications to use the same logging tools and the same monitoring tools. And so we find that to be incredibly effective as we build these systems that absolutely have to be bulletproof because of the nature of the regulated industry. We use VPC flow logs, again, everywhere. Every region has a default VPC, and so you need to turn VPC flow logs on everywhere so that you have an indelible record of what traffic has flowed, and you can monitor that in real time and take action if something is going on that shouldn't be going on. We'll talk in more detail about that. We're really deliberate about things like Amazon S3 configuration. So for example, we can ensure that we have a tagging scheme we'll talk about. So we identify resources like S3 buckets that might contain protected health information, or PHI. And if that's the case, those data have to be encrypted. And so until very recently, we ensured that any bucket that had PHI had some constraints in a bucket policy that would disallow an object to be uploaded that wasn't encrypted either client-side or with SSE. AWS recently introduced a new feature that kind of does that automatically at the bucket level, which is great. And so we can update that. You want to make sure that your buckets aren't publicly facing. There have been some pretty public breaches around that lately. You want to ensure that you're configuring IAM globally to do things like have strong password policies with expirations and password complexity requirements and not being able to reuse the same password and that sort of thing. You also want to make sure that when you're configuring IAM, you never give IAM users any access policies outside of groups or predefined policies. And we really like constraining that to groups because you can build constraints inside of groups that says anybody who's in this group must have multi-factor authentication, MFA enabled. And so we can monitor and identify users that are able to access administrative functions without the added security of MFA. And we just completely disallow that. So there are standard sort of configuration principles that we follow. You'll see this diagram, but as you can see, in a regulated industry, you have to take it a little bit deeper. Now, this is a simplistic diagram. The actual system diagram of Verge's system is a little bit more complex, but everything that we deployed across multiple accounts and multiple VPCs with incredible levels of segregation. And by the way, I changed all of the details, so it's a real diagram, but it's fake numbers. So just to give you a sense of how a complex system can fit into a reasonably simple set of design and deployment principles. So the process of migration seems pretty simple on the surface. We really had three stages, right? We gathered information about the source systems. We coded the target environment, and then we moved data and deployed. Now, we're going to talk a lot about why I said coded the environment. So that's a very deliberate word, because another principle that is very important to follow on AWS, I'm sure you'll hear it again and again, is automate the deployment of everything. You should never really be in the EC2 management console. You should never really be typing CLI commands. You should never really be logging onto instances, really for any reason. Because people make mistakes. And when people make mistakes in regulated environments, bad things like HIPAA breaches happen. So At Cloudticity, we have a saying. We prefer silicon over carbon because we think that computers do things more reliably than people in the case of repeatable things like deployments. And so we'll talk about some very specific techniques we use in the coding of the environment for customers like Verge Health. And then we'll talk about the deployment and migration process. Now, it's important to recognize when we get to the actual day of migration, I'll skip to the punchline. It was a non-event. And that's not because migrations are easy. That's because we designed, and we coded, and we tested, and we iterated, and we did performance tests, and we optimized so that when the actual cutover, the migration took place, it was easy. So again, all the numbers are changed. The first thing we did was gathered all of the information about the existing environment. And we did so in a very deliberate and very thorough manner so that we had a very, very clear understanding of what it was that we had to code in the target environment. And so we knew all of the sizes and speeds and feeds and exactly what existed. We decided to do a lift and shift in this manner because we had 3 months to get it done. We'll talk a little bit about some things we had to optimize along the way and why. We also made sure that we had a very, very clear understanding of network traffic flows so that we could design the appropriate subnet strategy and the appropriate ACL strategy and security group strategy and routing strategy. And we also gathered a lot of information about how servers were configured down to the finest degree of detail, patch level, what software was installed, what software wasn't installed, so that we could then codify that into code that executed that deployment on AWS. The other thing that we worked closely with Verge on was designing OS hardening guidelines. Here's a few of them, but it goes on for many, many, many pages. So we had very specific design principles that, again, we could build into code to deploy, and then we could build into monitoring to ensure that the target environment closely met and followed the configuration guidelines. So this was some of the prep work for getting the information necessary to start coding the target environment. The coding took place in 2 general phases. So the first thing that we like to do is we like to build environments exclusively using CloudFormation. That's our preference, and whether you write it in YAML or in JSON or whether you prefer Terraform, it's irrelevant. What matters is that you're using some sort of templating process so that you have all of your server definitions and your environment definitions built before you deploy a single thing to AWS. Notice a couple of things. We have a lot of stacks. And this was, I think, before we finished. So we have a very extensive set of CloudFormation templates that we design and build at a highly granular level, and then we assemble them as nested stacks. So we've got a very fine-grained set of primitives, almost, that we can assemble in nested stacks that result in a fully defined environment in really, it could be one or just a handful of master nested templates. The other thing that we do with CloudFormation is we parameterize heavily. Because if you have a different CloudFormation template for every minute variation of your system, you're going to end up with an unwieldy amount of code. You're going to violate the don't repeat yourself principles. If you find a bug in a CloudFormation template, you're going to have a whole lot of code in other templates. So we like to boil it down to very discrete templates that perform very discrete actions, like deploy a load balancer or create a security group. And we like to highly, highly parameterize those templates so that we can reuse them in a very, very flexible manner. Another technique we really like to use is conditionals. So essentially, you can program if-then statements into your CloudFormation, and so you can have the same CloudFormation template act slightly differently based on the existence or lack of certain variables. You can, for example, have a single EC2 instance template that could have as little as 1 EBS volume, as many as X EBS volumes, by having EBS 1, 2, 3, 4, 5 as conditionals. So these are useful techniques that we've been able to take advantage of to help build rationalized environments for Verge Health in a way that is reusable, is in a don't repeat yourself manner, and is highly flexible in composing the target environment. We also do some interesting things around using metadata to drive configuration. So you'll see certain things. We've got tagging for EC2 instances, for example, where we can define for that instance, how does patching work? Does it or doesn't it contain PHI? Should we or shouldn't we install, in this case, Trend Micro Deep Security, which is the file integrity monitoring and anti-malware protection information. We can define environments so that we can do things like configure development in different ways from prod, and we can do that automatically. We can monitor instances automatically. We can break out costs differently for a more rational way of defining, especially in a SaaS platform, what costs what, and which customers cost what, and that sort of thing to help with pricing and profitability analytics. I'll get to the interesting part. Some of the cooler things that we do in a migration like this is to let the metadata actually drive the further configuration of infrastructure. So you notice here in the metadata, we've got things like chef environment and chef role. So this allows further code, once the instance has been deployed, to introspect the metadata and operate differently based on what the role is. So here we can have either a single or a small subset of pre-hardened AMIs that we can patch later on, but that once they come up in the auto-scaling group, they automatically tell AWS, hey, configure me this way. I'm a web server versus an AD server versus a database. So we use things like CFN init in the user data section, which we deploy through CloudFormation, which instructs the instance to execute some code. In this case, it pulls some code from an S3 bucket, which in a Linux instance, it'll be Bash. In a Windows instance, it'll be PowerShell. But that goes through, introspects the metadata in the tags, automatically installs Chef, and instructs Chef to configure that instance as it is supposed to be configured. The next thing we had to think about was, now that we have the environment coded, which means we can then hit the button and deploy it, we have to think about how do we move data, right? So we had the environment up and running, and then we wanted to get it running in parallel, so we had to start moving data. So we took a look. It turns out there are three types of data we had to worry about. There are files, there are databases, and there's shared storage. So for files, we did scheduled rsyncs. And that was easy. And if we wanted to refactor pieces of the application to use S3 instead of block storage, we would do AWS sync to S3. For databases, we could either do a database export and import for smaller databases or asynchronous replication to the target database, which over time would catch up and become nearly synchronous without putting load on the source database. And for NAS storage, we just had to find a way to replicate NAS in the cloud. Now, as it turns out, there are some challenges with some of these things. So I said earlier that we did some optimization during the migration process. So if, for example, databases were kind of tough because in a data center, in a physical data center, you can take advantage of things like direct attached fiber channel storage where multiple nodes of a database are sharing a single physical storage cluster. That's not an option on AWS. And so we had to refactor a little bit. We built Windows Server failover clusters with SQL Server always-on availability, which uses replication instead of shared storage, but it still does automated failover. And then we added some nice things like automated backups to S3 buckets, which will migrate to Glacier on a defined schedule. So there's an example of actually a better optimized data-based management system with high availability, with automated failover, that also added regular scheduled backups using SQL Server Agent in this case, and then regular migrations of those backups automatically to Glacier. For NAS, there was no direct approach that we could use. AWS has EFS, Elastic File System, that is not HIPAA eligible, unless they've announced that today, but also is not usable in extremely high volume transfer environments, because it uses a credit system, and if you're transferring large volumes of data, you'll quickly consume your credits. So we turned to a product, SoftNAS, deployed from the AWS Marketplace. It is an EC2 instance that is a NAS appliance. The other thing with ECS, or with Elastic File Store, is it doesn't support anything other than NFS. And because, as James mentioned, this is primarily a Windows environment, we had to do CIFS shares as well. So SoftNAS was how we solved that problem. James mentioned that they have VPN connections. As it turns out, they have a lot of VPN connections. And moving point-to-point VPN connections is not really feasible, particularly for smaller hospitals and that sort of thing. So fortunately, the VPN connections were concentrated at a provider called ANX, and we were able to keep that in place so that there was really no change on the client end. So we didn't have to update 900 tunnels, but we're able to then route ANX back through the Palo Alto devices. And so that became a relatively trivial thing to do. So those were some of the special considerations that we had to follow while we did the migration. And the migration, again, it took place on a Saturday, and most of us spent the afternoon with our kids. So at this point, we had the environment up and running in parallel. We had automated data movement happening. So the migration process really consisted of stop accepting production connections, wait for all the syncs to complete, move the VPN connections so that they're now connected via ANX to the Palo Alto device, update the DNS host addresses, and start accepting connections at the new environment. This was not easy. This sounds easy, but the migration didn't take place on a Saturday. The migration took place over 3 months, and it just finished on a Saturday because everybody on the team, especially the Verge Health folks, did a great job of ensuring that everything was tested, validated, vetted, optimized, and working as designed. Post-migration, we started to do some more things. So one thing was we added a lot more cutting-edge security. So at the ingress-egress piece, using the Palo Alto devices, they support a lot more than just sort of inbound traffic management. So we were able to leverage things like geo-based routing. So I doubt that Verge has customers in North Korea. We could effectively block that. We were able to do things like inspect SSL traffic. We were able to do, put on application-based routing and that sort of thing. So the second thing we did was we added Trend Micro Deep Security, which is an agent-based product that monitors for security events at the instance level. And so through those two actions, we actually significantly optimized Verge's security footprint. The fact that they're on AWS now is actually a strategic asset to them from a security perspective because of some of the features and functionality that we've been able to leverage on AWS. We also really started to focus on what can we do to create more agility for their team. And so we identified things like common requests that would come in to create new instances or create stacks. And we were able to build fully automated deployments of that and deploy them to Verge personnel through the AWS Service Catalog. And that way we could give, say, development teams the ability to quickly spin up or bring down entire development stacks without having to have IAM access to the underlying resources. And so the ability to self-provision, but without all of the underlying administrative access, was a really important piece of the post-optimization process. As you can see, here are some examples of stacks. Like we have very granular levels of stacks that Verge Health can access through Service Catalog and have really fine control of their infrastructure without all of the associated IAM access that goes along with it. We also focused very heavily on availability, and we immediately realized two things, right? So one is, because the entire deployment is scripted, because it's it's parameterized CloudFormation templates. It's parameterized chef cookbooks. If an entire region goes down, it's not that hard of a thing to redeploy in a different region. And so in executing solid design principles, we kind of had DR built in. And as we talked about, because of the standardized VPC configuration, we also had availability built in. We even did things like the Palo Alto devices at the time did not support failover between nodes. And so we built some automated tooling using Lambda and API Gateway and CloudWatch alarms that if it detected a failure of a Palo Alto node, would automatically remap all of the ENIs, the Elastic Network Interfaces, over to a new set on the secondary. It would remap Elastic IP addresses. It would, using Lambda, essentially go through the configuration file and do a big sed to replace IP addresses and routing tables to the new ENIs. And when we had a couple of failovers, they would happen in about less than 10 seconds. And so, we were able to leverage the flexibility and the programmability of AWS infrastructure to really provide a much more highly available environment without really adding a lot of cost. Speaking of cost, we are closely aligned with CloudCheckr. And so we're able to continuously help Verge Health optimize their costs. So for example, CloudCheckr gives us the ability to do analytics around reserved instance purchases. And so as their business evolves and their usage changes, we can continue to identify opportunities to save money through purchasing of RIs. We can also identify infrastructure that's either overutilized or underutilized. And so we can continually provide recommendations around things like, hey, you might want to turn your development environment off at night. It's not being used. Or this instance is oversized or undersized. And so we're able to see continuous cost improvements so that cost is always aligned with usage. We use a management platform called Cloudticity Oxygen that provides 24/7 monitoring of speeds and feeds, incident management help desk. We have some interesting automated patching going on we'll talk about in a second. We do continuous compliance checks where we're constantly scanning both the AWS configuration but also the operating system configuration for things like CIS profiles, for things like instances that are tagged to store, process, or transmit PHI that are connected to unencrypted EBS volumes. And those can automatically trigger help desk tickets. Right now, our help desk is about 60% remediated through automation, so no human ever touches it. So as a result, Verge Health experiences a higher degree of uptime, but a higher degree of visibility into their compliance footprint, and a higher degree of guarantee that certain types of compliance deviations will be fixed automatically, which is critical, again, in an industry that is managing HIPAA and PHI. We use things like step functions to affect automated patching, and we can do really interesting things with that, right? So not only automatically patch and determine if it's a Linux instance or Windows instance, we can take the outputs of things like Nessus scans and identify the specific CVEs that need to be patched and feed only those into the patch program. We can do things like dynamically patch SQL Server clusters by patching the secondary, failing over, patching the primary, failing back. So any type of sequence-based event can be programmed very effectively in AWS step functions. So that's another service that'll be your friend if you really want to automate the management of a system that requires absolute adherence to compliance frameworks and an absolute guarantee that things will happen the same way each and every time. We do some interesting things around data monitoring. So we're using a lot of data collection. We collect data from anything that generates data. We pull that into Kinesis streams. We can do real-time analytics on that. So we're using things like unsupervised machine learning models using random cut forest algorithms that can, within 2 weeks, identify what does normal traffic look like? What does normal IP traffic look like? Because we're feeding VPC flow logs into the Kinesis streams, but also into Lambda functions that will do geolocation dynamically. And so after about 2 weeks, we can identify anomalous behavior. We can persist all of those data to a data lake for later analysis retroactively. But we can also feed those anomalies to a separate set of Kinesis streams that can trigger Lambda functions that will trigger things like automated tickets, or in the case of something really bad, a page and an incident getting opened. So using AWS native functionality, we can bring a ton of safety and monitoring and visibility into a HIPAA compliant workload. So after that migration and then the post optimization, I'd like to ask James to come back and talk about some of the benefits that Verge Health experienced.
Thanks, Jared.
Thanks, James.
Maybe yes. Okay, everybody hear me? Great. So sounds easy, right? I will say one thing from Jerry's perspective. So we did this in 90 days, the first part there. And when I say we did this, I have a team, a few folks that are here. A lot of work went into this, both working with the Cloudticity folks and also with our internal folks. But over those 90 days, we made a pretty significant decision to make a large wholesale change to our environment. So to understand the scope there, that's really hundreds of servers, terabytes worth of data, and all of this was happening while we didn't impact customers. Interestingly enough, we had our user group in Charleston a month or so ago, had a conversation that the user group was able to stand up and ask if anybody knew that we actually moved to Amazon Web Services, to raise your hand. Now, we had sent out emails, of course, to people, let them know. It's a good marketing opportunity, too, to let them know that we're enhancing security, et cetera. But very few people really knew that we moved. And from an IT perspective, that's great. You don't want anybody to know that you exist, honestly, because if they know you exist, then there's a problem, right, primarily. So that was really good for us. It was a complete leap forward in regards to our security posture also with Palo Alto, Trend Micro. Our security and threat prevention just moved, light years ahead. And, for anybody who is in software sales, I've been in software sales for a long time, we transitioned using AWS really for IT as an asset. So where before we would have to go through a lot of lengthy sales process, and at the end of the sales process, the last box you had to check was the IT security review or the IT review, and you always have to cross your fingers that everything's going to work out. Now that's a non-event. We provide a document that says, here's all the things that we've done, here's where we're out in front, and it's outstanding. So really, IT is an asset on our side now. And that's a big deal when it comes from a sales perspective. Additionally, we've turned into understanding, at least internally, IT as being a cost center to really being an innovation center. And some really cool stuff that we're doing future forward, and some of the products that we're looking at with some of the AWS tools as well. Also, I can't stress enough, we talked a little bit before about those quick hit projects that we could do, and that we could spin up environments and do those quick hit projects, and that's really fantastic. I will say, in all the interviews that we did beforehand, asking questions about what went wrong with AWS implementations or Azure implementations, one of the largest things we found was that customers or people that gave us those references would tell us that the ability to spin up things is bad because they would have their internal folks spinning up environments, and then at the end of the month, their numbers would come in way skewed. So we built some pretty stringent technology and processes to make sure that those costs don't get overrun every month. Also, when Jerry was talking about the standardization component there of being able to press a button and start up instances, we spent a lot of our time in going back and looking at this, not only in this software company, but other software companies I've been in the past, trying to figure out what's wrong with the environment. What happened? Why is this occurring? And one of the big pieces for that is always looking at the setup for individual servers, right? Oh, this wasn't set up this way. In this case, that goes away. It's set up the same way every time, and every one of them acts the same way. And that is a tremendous, setup issues just go away effectively. Or you get them across everything, right? But it's really comforting for me as CSO to be able to say that we can go spin something up and understand it's going to predict and it's going to work like it's supposed to do every time. So really, things that took days also take moments. We talked before about being able to predict the bare metal spend and understanding what you were going to be doing. Now those are moments notice. We can spin up environments, et cetera. Also for me, I like having the ability to have full visibility into the environments. So we talked about Cloud Checker before. I like to understand from a P&L perspective on not only each environment, but each project that we're doing, what does that cost our organization? And really take that back to product management and executive leadership and say, listen, this is great, but we're going to cost this, and if we're all good with that, that's great. But we didn't have that ability before. Having that is huge to make data-driven decisions versus decisions based on gut specifically. Also, I can't say enough about working with the guys at Cloudticity. Those guys are really not a vendor so much for us anymore. They're more of team members for us as an extension, using Slack channels, et cetera. They continue to iterate that. And I also got to say, too, I can't say enough about my guys. I got two guys here that spend a lot of time working on this project, Matt Wilson and Tom. Tom, I appreciate all the hard work that you guys did. There's a lot more folks back at the ranch, but while it looks easy, it was quite the uphill battle to get it done. But we did it in 90 days. So I think that's it.
Great, thanks. We can take some QA. Last thing I'll mention is Cloudticity released today a fully automated HIPAA assessment that we're offering for free for kind of a limited time. So you can stop by our table at the end if you're interested. We come in externally and within about 5 hours present a pretty long PDF report that is the result of a few thousand compliance checks against your current AWS environment. So stop back if you're interested. And with that, we'll take some Q&A. So if anybody has any questions, we got mics, so somebody can come forward. We got a question right here.